Okay, so we're finishing up notes for 1-4. We're looking at example 3, this one talking about division, talking about those division rules. So again, just like above, the bases have to be the same. Just like with multiplication, you need to have the same bases. If your bases aren't the same, there's not really much you can do. And so then if your bases are the same, you can subtract your exponents. So, for example, if I have x to the 5th divided by x to the 7th, that would give me x to the 5 minus 7, because you're doing top minus bottom. 5 minus 7 is -2, which I can just turn into, if you remember with negative exponents, maybe you don't, x to the -2 is fine, or you turn that into 1 over x squared. And a lot of you make better sense about this if you think about, if I expand that on the top, I have 5 x's on the top. If I expand the bottom, I should have 7. If I cancel them out, I'm left with 2, and those 2 x's belong on the bottom, which is why we end up with that x squared on the bottom, not on the top. So let's take a look at our example. And I'm going to do this one in the expansion terms because I just think it's so much easier to expand it. I'm going to use purple. So x cubed, that means I've got 3 x's on the top, 1 y, and 1 z, because neither z or y have a visible exponent. 1 x on the bottom, 2 y's, and 1 z again. Let's cancel some stuff out. One of my x's cancel out because x divided by x is 1. One of my y's cancel out because y divided by y is 1. Z's cancel out because z divided by z is 1. So I'm left with 2 x's on the top, which is x times x, which means x squared, and just 1 y on the bottom for a final answer. Not too bad, huh? Not too bad. And then the last example we're looking at here talks about when you have exponents raised to exponents. This, the bases don't need to be the same for. You just need to pay attention to where the parentheses are. So I'm going to watch the parentheses. Watch the parentheses. And when you're doing exponents to exponents, you are multiplying the exponents here. You're multiplying those pieces. So, for example, if I have something like 2x squared y, and I have an exponent of 3 on the outside, that 2 would get the exponent of 3 now, because the exponent on the 2 is a 1, and 3 times 1 is 3. X would turn into a 3 times 2, which is 6. And y has an exponent of 1 just like the 2 did. 3 times 1 gives you a y to the 3rd. And then you could take one more step and actually do 2 to the 3rd power, because that gets you a nice normal number. 2 times 2 is 4, times 2 is 8, or just type it into the calculator. 8x to the 6th, y to the 3rd. So let's look at this final example here. Very similar to the one we just did over here. So I'm multiplying that 2 by all of the other exponents in my parentheses. That 3 has an exponent of 1 on it. 3 to the 1st power, a to the 4th, and b has an exponent of 1 right now. So when I multiply that 2, that's going to turn in 3 squared. A to the 4 times 2 is 8. B to the 1 times 2 is 2. And just like we simplified that 2 to the 3rd power over here, we're going to simplify this 3 squared. 3 squared is 9. A to the 8th, b to the 2nd power, final simplified answer. Make sure you take some time, look at these notes, and try those homework problems. Use the examples to help you.